Hi class. So lesson 3 of this unit is called Power of a Power. This is a continuation of exponent laws from lesson 2. So the learning goals are the same. There's not going to be any new ones here. I'm just going to add one extra exponent law on top of what we did last time. And this exponent law is called the power of a power. And an example of that looks something like this. I'll have a power, let's say 2 cubed, and I'm going to take this power, I have it in brackets here, and raise it to another exponent. Let's use 4. Okay, so I've got two exponents going on. The exponent of 3 is attached to the base of 2, and then the exponent of 4 has a base of 2 to the 3. So that's kind of complicated. It's like we got a power nested inside of another power. So we call this a power of a power. Now, if you don't know any exponent laws and you need to evaluate this out, the long way around that you might take is to rewrite these things as repeated multiplication. So I'm going to go outside in. Okay, I'm going to go work my way outside in. So I'm going to first apply the exponent of 4 to the base of 2 cubed. So that means 2 cubed times 2 cubed times 2 cubed times 2 cubed. Okay, so 4 copies of 2 cubed all multiplied together. Now, what we have in the second line, you may recognize that this looks like, or this now looks like a question from lesson 2. Okay, so this actually now looks like a question from lesson 2. You have 4 powers multiplied together, and they all have the same base. The base is 2. So we can apply the law of exponents that deals with the product of powers with the same base. So to simplify this, that will equal to 2 to the exponent of all of these exponents added together. 3 plus 3 plus 3 plus 3. And that equals to 2 to the exponent of 12. Okay, 3 plus 3 plus 3 plus 3 equals to 12. So that is a simplified version of that. You can check it on the calculator if you want. You can just type in the starting expression very carefully with brackets and exponents. See what it equals. Then you can type in the answer 2 to the exponent 12. See what it equals, and they should equal the same thing. All right, so that's kind of the long way of doing this. Is there a shorter way to get to this simplification? So let's see if you notice anything between the numbers at the start in terms of the exponents and the number at the end in terms of the exponent. Is there any kind of relationship you see between those numbers? Well, if you don't spot it, perhaps also look at the second last line here. Look at those exponents. 3 plus 3 plus 3 plus 3. What's another way to think about 3 plus 3 plus 3 plus 3? Well, that's actually the same thing as 3 times 4. And 3 times 4 gives you 12. So all of those things in yellow that I've highlighted there, they're all equal to 3 times 4. Okay, so that is the connection, and that is the next exponent law I'm going to write down. So another exponent law. So this will be the third one. You had 2 yesterday. Power of a power. So in general terms, it will look like this. If you have a power, I will use a base of A an exponent of m, and I raise it to another exponent, and I'll use the letter n to represent that. Those a, m, and n are called variables. They can, their values can be anything. To simplify this, you don't have to write it out the long way. The shortcut is to just realize that it will simplify to a base of a and an exponent of m times n. And I write it as mn. So m times n. That is the shortcut for simplifying. We'll do some examples. The instruction will simply be simplify. So we'll start with just making up some numbers here. 3, let's say squared, raised to the exponent of 6. Okay, so to simplify this, you recognize this as a power of a power, and you multiply the exponents. So that would be 2 times 6, and keep the base of 3. So 2 times 6 is 12, and that would be the answer. 3 to the exponent of 12 is a simplified form. This is different than what we did yesterday. So I'm going to now put an example of what we would have done yesterday. Yesterday we would have done something like this. 3 squared times 3 to the 6. Okay, so this is not a power of a power. This is 2 powers multiplied together, and they have the same base of 3. So this one goes back to yesterday, and the answer, or the exponent law for this one, is to add 2 plus 6. So that simplifies to 3 to the 8th. Okay, so I will write that out so we're clear. This is a power of a power example. Whereas part B is not. Part B is an example from yesterday. Old stuff. And when you're doing questions, now they're all going to be mixed up. Okay, so just because this lesson is called Power of a Power does not mean all your homework questions will be a power of a power. Your homework questions are going to be a mix of all the exponent laws from yesterday and today, and you have to be really careful to read the questions carefully to know which exponent law to apply. We can try to get a bit more complicated. First of all, so the instructions are still to simplify. First of all, we can throw more letters in there. So I can say x6 to the exponent of 4. And this is a power of a power. This is a power of a power. So to do that, we multiply 6 times 4 to get our new exponent. 6 times 4 equals to 24. So the answer is x to the exponent 24. We can get more complicated by having 2 letters or 2 variables in there. So I can say, for example, x squared y cubed all together, and then exponent 2. Okay. In a case like this, I want you to take the advice from yesterday. I want you to only simplify the x parts and just ignore the y parts. And then after you're done that, do the opposite. Simplify the y parts and ignore the x parts. So if we just look at the x parts, I have x squared, and then it's raised to another exponent of 2. So that's going to simplify to x to the 2 times 2. So that's the x part. And I'm going to do the y part as well. So for the y part, I have y cubed raised to the power of 2. So the new exponent will be 3 times 2. Okay, so the exponent on the outside of the brackets, that 2, it ends up getting multiplied to both exponents of the x and the y. So that will equal to x to the exponent 4 times y to the exponent 6. So that is the answer to part B. So I guess what I'm saying is the exponent, so I'll use blue here, this exponent multiplies to both of the exponents inside the bracket. That is how that works. Okay, and we can get keep adding a layer of complexity here. So let's say I'll have x, y squared to the exponent of 4 times x squared y cubed to the exponent of 3. Okay, so now, like, all we're doing here is just making the question longer and longer, forcing you to just think about things a little bit more deliberately and more carefully so as not to make a careless mistake. So this is a multi-step question. The first thing I would do is I would take the exponent 4 here, and I would multiply it to both exponents inside its bracket. That will lead me to x to the 4, okay, because I had just x by itself. So that's x to the exponent of 1, and I multiply the 4 with it. So it's x to the exponent 4, and y to the exponent of 8, because 2 times 4 is 8. And I'll put that in brackets. Okay, then I'll do the same thing for the second brackets. I have an exponent 3 on the outside here. I will multiply that by both exponents inside the brackets. So for the x, I'll have 2 times 3, which is 6. And for the y, I'll have 3 times 3, which is 9. And we're just partway done. Now, what I have here is a question that looks like yesterday's stuff, a product. Okay, a product of powers with the same base. So I'm going to start with my x's. If you look at the x parts, I have x to the 4 times x to the 6. Okay, so that is going to be, those are going to combine to make 10 x's multiplied together. So x to the 10. And then if I look at the y's now, I'll look at the y's. I've got y to the 8, so that's 8 y's multiplied together, times y to the 9, so 9 more y's multiplied together. All in all, that's 17 y's multiplied together, y to the exponent of 17. Okay, so there is the answer to part C. And in your homework, it might get a little more complex by adding division into it. So just combining the exponent laws for dividing powers of the same base that we did yesterday. Another important example to do, actually, is with a fraction. So let's say you have 2/3, and we're going to raise it to the exponent of 4. Okay, so I'm going to actually show you this the long way again. So 2/3 to the exponent 4 can be thought of just by the definition of exponents with powers with natural exponents, repeated multiplication of 2/3, you have 4 copies of them. So we can think about 2/3 to the 4 like that. Now to compute this, we think about multiplying fractions. How do we multiply fractions? Well, fractions multiplied would be numerator multiplied by numerator over denominator multiplied by denominator. And if we have 4 fractions like we do, then it's simply all 4 numerators multiplied together over all 4 denominators multiplied together. So when you multiply all 4 numerators together, hopefully you'll see that's 2 times 2 times 2 times 2. How do we write 2 times 2 times 2 times 2? We write it as 2 to the exponent 4. And then in the denominator, all of them multiplied together is 3 times 3 times 3 times 3. And that's 3 to the exponent of 4. So I guess what I'm saying is when you have a fraction in brackets and it's raised to an exponent, what you have to do is you apply the exponent individually to the numerator and the denominator. Okay, the answer ends up being 2 to the 4 over 3 to the 4. So we can extend that, include some letters, and some higher exponents. So for example, maybe we have a squared over b, and that's going to go to the exponent of 3, like that. To do something like this, this is a power of a power. So this exponent of 3, I need to multiply that with the 2 for the new power of a in the numerator. And I need to multiply it by 1, because that's just b to the 1 in the denominator there, to get the new power of the denominator. So that will be, I'll write it out the long way first, 2 times 3 over b to the 1 times 3. Okay, so 2 times 3 is 6, so a to the 6 on top, and 1 times 3 is 3, so b cubed on bottom. That would be the answer to something like that. So those are all of the base skills you'll need for now for a power of a power. One key point is that it's different than the exponent rules from yesterday. And one of the big things you'll have to do for the homework or for the practice questions is to make sure you use the correct exponent law for each question, because you have 3 of them now. All right, so good luck with that, and we'll see you next time.